Alright, so today we are starting a new unit on exponents. So there's a lot of vocab, unfortunately, in this unit. So each box is a vocab term. So let's fill it in. The first one is called a monomial. Monomial. What does mono stand for? One. One. So a monomial is only one number or variable with a non-negative exponent. The best way to describe a monomial is to just give you some examples. So this is an example of a monomial. 10, 4 over 2, which is 2. 3, A, J, D. Basically, a monomial is you can have a number in any number of terms as long as you are not, so this is going to be the no category over here. No. As long as you are not adding them, so I can't add f plus 24. I can't divide by a variable, so I can't divide by f. I can't subtract either. I can't do e minus 2, but I can multiply. So I can't add, subtract, or divide by a variable. I can divide by a number, but not a variable. Yes, Dylan? Yes? Okay. You can multiply them together, but we can't divide, add, or subtract. Because a monomial is just one thing. When you add them or subtract them or divide by a variable, you're breaking it into two different parts. Yes. Okay? So a constant, the next vocab word is constant. A constant is a monomial that is just a real number. So shout out some real numbers. 6, 10, 22, 8. What about negative 4? You can be negative $4. That's a real thing. You can be in the hole $100. Negative 100 is a real number. Okay? So whenever you have just a number, that's called a constant. So in this case, 6y, what's your constant? 6. 6 is your constant. A constant is just a real number. What, Dylan? Just a number. A constant is just a number. Okay, so 1 through 4. Let's determine if these are monomials. So write yes or no beside them. Try it on your own. 1 through 4. Write yes or no. Yes or no? Kaylin, number 1, yes or no? No. Good job. Why? Good. So in parentheses, I'm going to put the reason it's a no. So in this case, it's because you are adding the exponent and the constant, which was separating it into two different things. Monomial is just one. Number 2, Caitlin Kendrick. Yes. This is a monomial. It's just one thing. Jonathan, number 3.
No.
Yes. Yes, you can divide by a number. You can't divide by a variable. So this is yes because what's in the denominator is a constant, not a variable. Allison, number 4? No. And that is because there's a what in the denominator? Variable. There's a variable in the denominator. Good job. So that is determining between a monomial and not being a monomial. The next term is called a power. Power. No, probably not. X to the nth power, that's a power. So X is being multiplied by itself in times. X is the base, X is the base, and N is the exponent in this case. X is the base, N is the exponent. So, somebody give me a number.
22.
That's too big for this. 4. Alright, 4. 4 raised to the 7th power. That's how you read this. 4 raised to the 7th power. So we have to multiply 4 by itself how many times? 7. So your 4 is called the what? The base. 7 is the power or exponent. Okay? You could call it power or you could call it exponent. So in order to determine this, we are going to multiply 4 by itself 7 times. 16,384. Alright, so there are 3 properties of multiplying our exponents. There's 3 different kinds. Here is number 1. The arrows are the properties. So here's number 1. It's called the product of powers. Product of powers. So I'm going to write down this little definition and I want you to follow. Yes, practice. To multiply 2 powers that have the same base, you need to add their exponents. For example, I need the same base. So if I'm multiplying exponents that have the same base, let's use x for example. I have x to the 3rd, and I have multiplying it by x to the 7th. So I have 2 powers, they have the same base, and I'm multiplying. So when I'm multiplying exponents, I really just add them. So when I'm going to combine them to have one base, I'm going to add 3 plus 7. So really it simplifies to be x to the 10th power. Have y'all seen this? Good. Okay, what if I add numbers to it? 3 to the 3rd power times 3 to the 6th power becomes what? Keep the 3, keep the base, So we're not multiplying our bases, we're only adding our exponents. So you keep your bases 3, and then you add 3 plus 6, which simplifies to be 3 to the 9th power. You cannot do it if they have two different numbers. This is only if they have the same base. Okay? So then you can go in and plug in your calculator.
Jasmine,
Yes, ma'am.
would you let Caitlin Cunningham know we have something in the main office for her to pick up?
Yes, ma'am. So you could go back in your calculator and plug in 3 to the 9th power. Or multiply 3 by itself how many times? 9. Good. Let's do some examples. Okay, so I'm looking at number 5. The first thing I want you to do, if there are two numbers that have no exponents, okay, they have no exponents, go ahead and take care of those. What's 3 times 7? 21. So I'm going to mark those out so we know they're taken care of. 3 times 7 is 21. Now, I have y to the 4th and y to the 5th left. Well, in order to simplify y to the 4th times y to the 5th, I'm going to add their exponents. So this becomes 21 y to the 9th. Okay, try the next one. What are you going to take care of first? The ones that have the constants, right? Constants are just real numbers. -4 times -6. Good. I'm going to bring down everything so you can see it. So I have 24. I have r times r to the 5th, x to the 2nd times x to the 2nd, t to the 3rd times t. Okay, so I just brought them down and put them where the bases that are similar, so the ones that have the same base, are beside each other. So now let's simplify. I have 24. R times r to the 5th. What if there isn't a base or a power on r? It's 1. Yeah. So what's r to the 1st times r to the 5th? 6. You have to add them. You have to add them. So x becomes x2 plus x2 is 4. T to the 4th. So when you're multiplying powers that have the same base, you really add them. Okay, here's our next property. Property number 2. What's it called? Power of a power. So here's number 2. Write this down and then we'll talk about it. To find the power of a power, you need to multiply their exponents. Multiply their exponents. I'm about to show you some examples. So what do I mean by power of a power? Well, let's say I have my base is x, and it's raised to the 2nd power. That looks normal, right? That's just a base with a power of 2. Now, I'm going to add a power to that power. So let's say x squared is raised to the 4th power. In order to do that, I'm going to multiply the powers. So 2 times 4 is, so this simplifies to be x to the 8th. Okay, what if I had 3 squared, and then that was raised to the 3rd power? 3 to the what? 6. Okay, well, what is 3 to the 6th power? What'd you get, Evan? Same thing? Okay, good. 729. So here's the difference. This is a power raised to another power. This is the same base where we're multiplying them and they both have exponents. Okay, let's do this example. Number 7. Oops. You need to be very careful, guys. This can get very tricky. 4 is raising everything inside the bracket. Okay, yeah, we need to distribute that 4 to the 2 and to the 3. But let's just do it to the 4 first. Yeah, leave the base alone. So we have 2 raised to the 3rd. Okay, that stayed the same. Now, when I'm distributing that 4 just right inside the bracket to the 2, what's 4 times 2? 8. Okay, well, I still have a power raised to a power, so I have to keep going. What's 8 times 3? So I have 2 raised to the 24th power, which comes out to be something crazy like 16,777,216. No. You can test me. I'm pretty sure. All right? Okay. So work your way from the outside in. Outside in. What's on the very outside? 4. Okay, let's leave what's in our parentheses the same. 2 to the 2nd power the same. So really, I'm looking at 2 to the 4th. Well, what's 2 times 4? 8. Now I have 2 to the 2nd, which is raised to the 8th. So that becomes 2 to the 16th. I have no idea what that is. 65,000. I know you said it. I couldn't hear the last part. All right, last one. Last property is called power of a product. This is property number 3. To find the power of a product, find the power of each factor, and then multiply. Okay, for example, I have 2xy squared raised to the 2nd power. 2xy squared raised to the 2nd power. So everything inside these parentheses is raised to the 2nd power. So let's rewrite it. 2 is raised to the 2nd power. Remember, if there's nothing, then it means it's a 1. So 1 times 2 is 2. Y is raised to the second, but we have to multiply it by 2 as well. Yeah, so it becomes 4. What is 2 squared? 4. So in the end, we have 4 and then x squared y to the 4th. All right, we have 2 examples on the bottom that are kind of difficult. So it contains all 3 properties we just used. This contains all 3 properties that we just used. So let's try it. The first thing I want you to do, you see how this 3 is raising everything inside the bracket? Let's simplify that part first. Okay, let's simplify the 3. So I'm ignoring this first part. Everything inside, it has to be raised to the 3rd power. So let's take care of the 3 and the 2. So what's 3 times 2? 6. So this simplifies down to be negative 2y raised to the 6th power. I'm covering up the first part because I don't want to worry about it yet. Okay? Now, everything inside the parentheses has to be raised to the 6th power. So negative 2 to the 6th and y to the 6th. So now let's come back and rewrite it. What is negative 2 to the 6th power? Negative. So your calculator, I know you don't believe this, your calculator will lie to you. It will lie to you. Here's a trick. Here's a trick. If you ever have a base, let's just call it n. If you want to call it x, that's good too. If you have a base, and it's raised to even power, 2, 4, 6, 8, 10, 100, it's going to be positive. In this case, we have negative 2 raised to the 6th power. So I need to write negative 2 how many times? 6 times. 1, 2, 3, 4, 5, 6. What's a negative times a negative? Negative times a negative. Negative times a negative. Positive times a positive. Positive times positive. Positive times positive. Okay? Anytime you have x or any base raised to an even, it's going to be what? Positive. Okay? What if I have a negative x raised to the 3rd power? It's going to be negative.
Well, you can't have a negative.
If that base is negative, if this base is negative but it's raised to the even, it's still going to be positive. Not only if it starts off as on. Okay, so let's say that again. Negative 2 raised to the 6th power is what? 64. Now let's rewrite it. So I have 3xy to the 4th. I just brought that down. And then 64 times y 6. 64 times y to the 6th. Okay, let's combine our constants. What is 64 times 3? 192. Okay, there's an x here. Is there an x over here? Nope. Nope. So x is just by itself. But there's a y over here, and there's a y over here. Okay, but it's just power. Yeah, this is just y to the 4th times y to the 6th. So then I just add them so you get y to the 10th. Okay? All right, let's skip number 10 for now. I want you to flip to the back. We have about 10 minutes, and I know this looks like a lot. But look at number 5. What's n to the 1 times n to the 5th? That's it. Okay? So, when I say that I want you to finish this page, you might freak out a little bit, but it really, like, all the way down to here, that's all you're doing. Okay? So I want you to try to finish this page right now.